omega t is equal to what? Pi. Yes or no? Right? From where? Anyone? From here. You see this? Overshoot. Okay. So it is so important to remember this what? This graph. Maybe the term test, I'll ask you to sketch this graph and label them. What do you think? Okay. Make your life easier. Yes or no? Yeah. Those freaking equation about vibration is killing us. So from here, we know that P is equal to pi over what? Omega. Why we want it to be T? Because this expression over here is in terms of what? Time. Yes or no? It's not in terms of what? Omega T. So from here, we know that X at pi over omega is equal to E minus zeta omega n multiplied by pi over omega, close bracket, then minus XSS cos omega multiplied by pi over omega, okay, plus by C2 sine omega bracket pi over omega, and then you have plus by XSS. Okay. So from here, cos of pi is equal to what? Minus 1. So we will write this. So this will be x pi over omega. This is equal to E minus zeta omega n bracket pi over omega, right? So this will be, so when you do this, this is equal to minus 1. This will be equal to 0. So this is XSS plus by XSS. So from here, we know that E or XSS E minus zeta omega n pi over omega plus by XSS. Okay, so this value is the steady state amplitude. This value is the overshoot. Okay, so therefore, the overshoot will be equal to XSS E minus zeta omega n pi over omega. Okay, so we know that we know that omega is equal to omega n bracket 1 minus zeta squared. This is known. We derived this before. So this expression will be XSS E minus zeta omega n pi divided by square root divided by omega n square root of 1 minus zeta squared. So finally, XSS is equal to E minus zeta omega n, or no more omega n, pi over square root of 1 minus zeta squared. To get the percentage overshoot is equal to XSS E minus zeta pi square root of 1 minus zeta squared over by XSS multiplied by 100%. So the percentage of overshoot is E minus zeta pi divided by 1 minus zeta squared multiplied by 100%. Did I make any mistake down here? Can you check for me? I'm not sure now. Is it okay? The equation is okay? Okay. So next, we go into subsidence ratio. So subsidence ratio is the second overshoot divided by the first overshoot. Okay. So that's where we come back to this diagram again. See how important this diagram is, right? So this is the first overshoot. This is the what? Second overshoot. That's why it's important to label pi, and then the next one is what? 3 pi. Okay. So first overshoot divided by second overshoot. Okay. So this expression will be, so the first overshoot is x, second overshoot e minus 3 pi zeta divided by square root of 1 minus zeta squared. The whole thing divided by xss e minus pi zeta divided by square root of 1 minus zeta squared. So this will become e minus 2 pi zeta divided by 1 minus zeta squared. The last one, settling time. Right, the last one, settling time. So when settling, we ignore the sine and cosine. So the function we should be focusing now is x as a function of time is equal to e. No, it's equal to xss e minus zeta omega n t. Okay. So we want our, what do we want our x as a function of time to be? Okay, so settling time is ts. Okay, so this I have to change to ts. So I want it to be 2% of xss. Okay, so this is, again, this is arbitrary number. You want to put it 5%, you decide. You want to put it 10%, you decide. I'm going to use for 2%. So when that's the case, I have 0.02 xss is equal to xss e minus zeta omega n ts. Okay. So from here, we will have 0.02 is equal to e minus zeta omega n t. To get ts, we have to put natural log on both sides. So natural log of 0.02 is minus 3.912. This is equal to minus zeta omega n ts. So ts is equal to what? 3.912 divided by zeta omega n. So for this stage, this is settling time. 2% xss. Are we okay so far? Formula is okay. Finally, we have to derive force vibration now. Okay, so let's go into force vibration. Oh, you're still copying? Don't copy. Okay, these are online for you. Okay, so the final one is force vibration. Force undamped vibration. Okay, so for this case, we have a spring. We have a mass. And then we have f naught sine omega naught t function. Okay. So now again, to assemble this, you need to find what is your general equation. So our our general equation will look like this, will look like m d squared x over dt squared plus by c dx by dt plus by kx is equal to f naught sine omega t. We are going to drop this because this is equal to what? 0. Okay. So what we have now is d squared x over dt squared plus by k over mx plus by equal to f naught, right? F naught over m sine omega naught t. And this solution, x as a function of time, will be equal to C1 cos omega t plus by C2 sine omega t, right? And then plus by a function. The function over here is x. I'm stuck now. Sine omega naught t. Am I right? No, not. Yeah. Okay, I'm going to leave it as that. Okay. Now the omega over here, is equal to square root what? K over m. Okay. So we are going to let. So we also know. Okay, we also know that this is the transient, and over here, this is the steady state. So from here, we are going to let x t is equal to x sine omega naught t. Xp dot is equal to x omega naught cos omega naught t. Xp double dot is equal to minus x omega naught squared sine omega naught t. So we substitute everything into this equation over here, right? So we have minus x omega naught squared sine omega naught t plus by k over m x sine omega naught t, and then this is equal to, is it equal to f naught? Yeah, f naught over m sine omega naught t. Okay. So from here, we can take out our x sine omega naught t. So this will be equal to k over m minus by omega naught squared. This will be equal to f naught over m sine omega naught t. So we can get rid of this. We can get rid of this. X, which is the amplitude, bracket k over m is square root omega n minus by, or I just call it k over m, minus by omega naught squared. So this is equal to f naught over m. X in this context will be equal to f naught over m over square root or over this value. So we know we're going to take out k over m. So 1 minus by omega naught squared. So when we take out K over M, this is we divide by what? M over K. So you can cancel this, you can cancel this. This is equal to FO over K divided by 1 minus by omega naught squared over omega n squared. So far, are we okay? Sylvie, file still there? I'm going to stop here. Hey, listen. Listen and listen well. We have derived what? 3 pages. Okay? I can do it. Okay? Yeah, very good. Okay? If that's the case, hey, don't panic. Be responsible. Are we clear? I'll see you guys tomorrow. And tomorrow, 4:30 to breakfast. How are you going to fight such a excited but don't be patient? Here's the behind. No, I'm not. Please, I need to find one. Is it that bad?
Question. Why don't we stop at traffic?
Next Friday.
Next Friday, last month.
Yep.
37 minutes.
Yep.
Thank you.
Go on.